In question number 21, there are three identical special dice on the table. What is the sum of the numbers on the faces that touch the table? Okay, now if you look at the numbers here, 22 and 13, they have a similar a common side here. And 22, the direction of 22 from the button to up, and this one has this direction. So if we look now here at this 8 and 13, so we will notice that this 8 is under 13, so we will write 8 here. So, and now if we look at this one here, 8 and the 22, we notice that this 22 is under 8, so we will write 22 here. And now here, if we compare this 8 with the 13, so in under this 8 should be 13. So now if we sum all of these three numbers, we will obtain 8 plus 22 is equal to 30 plus 13 is equal to 43, and C is the correct answer. Okay, now in question number 22, the diagram shows four touching rectangles. What is the area of the shaded rectangle in square centimeters? Okay, first of all, we have this side as 5, and the area of this rectangle here is 45. So if we divide 45 by 5, we will obtain 9. So this part will be 9, and the remaining here will be 4. Okay, now if we divided 40 here by 4, we will obtain 10, and this is the length of this side. Okay, what is the remaining here is 6. So if we divided 48 by 6, we will obtain here 8. So this one is 8. Now, how can we find the width and height of this rectangle here? This one. So at first, let's find this part here, the height. So we have this one as 4, and we know that all of this one is 8, so this one is 4, the remaining. And we know that here we have 10, and we know that here is 5 because of this one here. So this one is 5, so the remaining here will be 5. So the area of this rectangle will be 4 multiplied by 5 equal to 20, and E is the correct answer. Now in question number 23, the figure shows the plan of 7 train routes of a small town. The circles indicates the stations, but one wants to paint the lines in such a way that if two lines share a common station, then they are painted with different colors. What is the smallest number of colors that he can use? Okay, first of all, to solve this question, let's paint the lines that are parallel to each other, the vertical and the horizontal lines. So I will start with the vertical ones. So I will color this one by red, and this one by red, and this one by red. Now I will paint the ones that are parallel to each other horizontally. I will use different color here. So I'm gonna paint this one and paint this one. Now I still have the line number 2 and the line number 7, and because number 2 and 7 are crossing more than one color, so I should use different color here, because 2 is going through 6 and 5, and they are red, and through 4 also, and they are going and crossing also the line 1, and one is green, so I should use a different color. So I will paint it with blue like this, and the same situation for 7, so I will paint this one also with blue. So what we conclude from this, that the minimum number of colors that should be used is 3, and A is the correct answer. Okay, now in question number 24, Walid wants to fold the net shown to make a cube. He wants the triangles that touch the edges of the neighboring faces of the cube to be shaded with the same color. How should he shade the triangles of the unshaded square in the net? So now we want to shade the colors here of this square here according to the squares here. So this one, this square here will touch this square from here, and this square from here, and this square from here. So I will color each one differently. So I will use this one for this part, and I will use this color for this one, and I will use this color for this one. Okay, now let's look at the nearest one, which is the red. We have these two need to be shaded, this one and this one. Okay, now let's look at the green one. Okay, this one will be corresponded to this one, and this one will be corresponded to this one. So we should color this one. And now if we look at the blue, this one will be correspondent with this one, and this one will be correspondent with this one. So we will color this one here. Now if we look at the yellow one, we should color this one here. So if we look at the answers, B is the correct answer. Now in question number 25, Sammy takes 4 cups out of the cupboard and puts them randomly on the 4 saucers. Which statement is correct? Now let's check the first statement, A. In the first statement, it is certain that none of the 4 cups stand on its matching saucer. So this certain cannot be true, because maybe and randomly one or more cups will be stand on its matching saucer. So this one is not correct. It is certain that exactly 1 cup stands on its matching saucer. This one also not correct. Maybe all of them are not standing on its matching saucer, so this one is also not correct. Now the third one, it is impossible for exactly 2 cups to stand on its matching saucer. Also this one is not correct. Maybe 2 or more, or it's possible for 2 or more to stand on its matching saucer. Now let's look at D. It is impossible for exactly 3 cups to stand on its matching saucer. Actually, this one is true, because it is impossible, because if 3 stand on its matching saucer, so the 4th already technically is also standing on its matching saucer, so it will be 4. So we will not have 3 here, we will have 4 in this condition, and this statement is correct, and D is the correct answer. Okay, now in question number 26, a cube with the field in numbers is given. Mariam wants to write the numbers 1 to 8 on the vertices of the cube. She wants the sum of the numbers of the vertices around each face to be the same. She has already written the numbers 6, 7, and 8 as shown. What number should she write on the vertex marked with a question mark? Okay, now let's sum the digits or the numbers from 1 to 8. If we sum from 1 to 8, we will obtain 36. So 36 will be divided, for example, if we divided this cube into 2 parts, so we will have 4 vertices here, and we will have 4 vertices here. So if I divided this 36 by 2, I will obtain 18. So in each place here will be 18. For each 4 together, it should be 18. Okay, now let's start with a face that contain more than one known number. So I can start with this one, for example. Now I have 7 and 8. So if we add 7 to 8, we will have 15. So I need extra 3. So I can obtain 3 by just adding 1 to 2. So I will obtain 3. So I should fill here these two circles with 1 and 2. Okay, let's for example try now 2 here and 1 here. Okay, now let's sum the digits here. So I have 8 plus 2 is 10, plus 6 is 16, so I need extra 2 here, but I cannot put like two twos, so this is not correct, and I will put 1 here and 2 here. Now I have 15. Okay, 15, I need extra 3, so this one should be 3 here, and the correct answer is C. Okay, now in question number 27, a grandmother has some candy. She decided to divide them up amongst her grandchildren so that each has a bag containing same number of candies. She puts the largest possible number of candies in each bag, and when she is done, she sees that there are 20 candies in each bag and 12 candies are left over. What is the smallest possible number of candies she could have? Okay. Because we have remaining, she has the remaining of candies is 12. So the number of bags should be bigger than 12. And we want the smallest possible number of candies. So we will take 13 as number of the bags. Each bag we have 20. So if we multiply 13 by 20, we will obtain 260. And we have the 12 that still with the grandmother, and if we added these two we will obtain 272, and C is the correct answer. Okay, now in question number 28, Hassan plans to cut a rope into 12 equal pieces and marks points where he needs to cut. Muhammad plans to cut the same rope into 16 equal pieces and marks points where he needs to cut. Then Mayar cuts the rope at all the marked points. How many pieces does Mayar get? Okay, now let's imagine we have a rope here and with two ends. Okay, and this rope is divided into pieces, and also the Muhammad marked it with another sign, so we have here and here and here, and maybe we will have common signs between them. So the trick here is not to add directly 12 and 16 and obtain 28. This one is not correct. So what we have to do is to find the greatest common divisor between 12 and 16. So what is the greatest common divisor? Is 4. So 4 is the greatest common divisor, and we will have 4 common marks between mark points between these two. So we will subtract 4 from 28, and we will obtain 24, and A is the correct answer. Okay, now in question number 29, Iman is playing with the 7 caterpillar puzzle pieces shown. She wants to build a caterpillar that has one head, one tail, and either 1, 2, or 3 puzzle pieces in between. How many different caterpillars could Iman build? Okay, now how many heads do we have? We have 2 heads. Here, this one and this one. And we have 2 tails, this one and this one. And we have these 3 in between. So let's give numbers for each one of them. So 1, 2, 3, 4, 5, 6, 7. And now let's count the possibilities for each one. Now at the beginning, if I select 1 as the head and 6 as the tail, so according to this one here, this part here, so I am forced to put 4 in between, because this 6 can only go with this 4, can be connected to this 4. So I'll put here 4. Now, and this is the first possibility, 1. The second possibility is to put 1, 4, and 6, and between them I will put another piece, so I may put here 3 also. So this is the second one. Another one is to put instead of 3, 5, 5, 4, 6. This is the third. And another one is to put 1 and then 3, and then 3, 5, 4, 6. This is the fourth possibility, and I can exchange these two, swap between them, and put 1, 5, 3, 4, 6, and this is the fifth one. Now, if I used another tail, like instead of 6, I will use 7, so I will have another extra 5 possibilities, so I will have 10 possibilities. Now, if I used the second head, this one, instead the first one, so I will have another 10 possibilities. So I will multiply this 10 by 2, and I will have 20 in total, and E is the correct answer. Okay, now with our last question, Yara writes a 3-digit number on the whiteboard. Then Bender writes a 4-digit to the right of the previous ones. He says, look, the number increased by 2024. What digit did Bender write? Okay, at first, let's write A, B, C as the 3 digits that Yara wrote. Now let's write also D with another color, the digit that Bandar added. Okay, now if we subtract this number from Yara's number, A, B, and C, we will obtain 2024. Okay, now A minus blank is 2, so A is 2. A is 2. Now B minus A is 0, so B is also 2. Now C minus B, which is 2, is equal to 2, so C is 4. Now D minus 4 is equal to 4, so D is equal to 8. Okay, so the number that Yara wrote is 224, and Bandar added this digit, which is 8. Now if we subtract this number from 224, we will obtain 2024, and D is the correct answer. And by solving this question, we have finished this exam, and see you in the next video.